I'm audible now. Am I audible?
Yes, sir.
Okay. Very good afternoon to all of you. I hope you already aware with the rules and instruction how to carry out the discussion. Okay. Ankit, Jyota, and Kashavi will monitor and maintain the flow of the discussion throughout the session. And while participating in the discussion, you'll raise your hand by yourself. And when you'll be allowed, then you'll unmute yourself and start discussing the topic. Okay. And you can use your means you can share your screen to show some relevant diagrams or the slides with respect to that topic, right? So always first introduce yourself, then we'll discuss about that topic. Okay. Now I am handing this session to Ankit, Jeta, and Kasabi. Please start the session, right? Thank you. Please start.
Good afternoon, sir. My name is Kashyapi, and now I'm going to discuss on the topic naive-based classification algorithm. So, what naive stands for? Uh, naive, say, what does naive means? So, every feature in this algorithm, every feature has its own dependent contribution towards recognition of an object. So, the presence of a particular feature is unrelated to other features. So the meaning of naive is being unexperienced or lack of experience. So this model is easy to build, useful for very large data sets. So uh, the equation for Bayes' theorem is posterior probability of class data is equal to posterior posterior probability of data of the class into prior probability of class and divided by the uh, probability of the posterior probability of the data. So what does posterior probability is? It is the probability that will happen after all evidence or background information has been taken into account. So the calculation of posterior probability will be the prior probability plus new evidence, that is the likelihood. And then the prior probability is in this probability, an event that will happen before all evidence or background information is taken into account. Then uh, posterior distribution. It is like posterior probability. What we have seen and observing is a posterior distribution, observing from background data in past, that is prior distribution. And the working of naive-Bayes theorem is convert the data set into a frequency table, create likelihood table, and calculate posterior probability. Thank you.
Sir, how to share the PPT?
So, good afternoon, everyone. My name is Jyoti, and I'm from Integrated MSc IT 9th semester. So, our topic is naive-based classification algorithm. So, this classification algorithm was being proposed by BEST with an assumption of independence among predictors, which means that the presence of a particular feature in a class is unrelated to the presence of any other feature. So let's take an example of a water bottle. So let's assume that it's yellow in color and it's cylindrical in shape with a round cap. So this can be considered as features. So when these three are considered together, it describes the object. But these three features contribute independently to determine that it is a yellow color bottle. So it's known as naive. So naive-based model is easy to build and particularly used for very large data sets. So posterior probability can be calculated by taking posterior probability of class C target given predictor X is equal to the multiplication of the likelihood into the class prior probability divided by the predictor prior probability. So prior probability represents what is originally believed before new evidence is introduced. And the posterior probability is the probability of an event that will happen after all the evidence has been taken into account. So now the working of naive-based algorithm. So step one will convert the data set that we have collected into a frequency table. So creating likelihood table by finding the probabilities. And third step is that after that we'll be using the naive-based equation to calculate the posterior probability for each class. So the class that is found with highest posterior probability is the outcome of the prediction. Thank you.
Okay, so good morning, everyone. So my name is Ankit from 9SEM. Actually, there is a problem while sharing my PPT, but then also I want to explain. So before net-based, I want to discuss about the decision theory actually. Suppose, for example, there is a two category for the product that we may take as W1 or W2. So take W1 as accept category and W2 as a reject category. So what will happen if we take the probability of PW or PW2, if we calculate independently, then if P1 PW1 value is greater than PW2, what will be the result? It will be W1. So the thing is that just by the prior probability, we cannot take the decision because suppose in the data set new data is found, and if it is rejected also, then it will go then also it will accept. Why? Because the prior probability W1 independent value, it is greater, right? So we have to combine different features and all. So there, how it's come about the naive algorithm. So what is naive algorithm? That is the algorithm that learns the probability of an object which certain features belonging to a particular group or class. Suppose, for example, if you are trying to identify a fruit or animal, anything. Suppose fruit. Suppose it is based on different color, different shape. So suppose the shape is orange, spherical, and the taste is tangy. Then what will be? It is we can by this property we can understand that the probability of this fruit is orange, and that is what is known as naive. So as by the naive and the bias is the name of the statistician, that is the Thomas bias, and we get the equation that is P A by B equal to B P B by A into P A by P B. So here P A B P A by B is the probability, that is the conditional probability of occurrence of the event A given by the event B is true, and probability A and B are the probability of occurrence of the event A and B respectively, and probability B by A is the probability of occurrence of event B given by the event A, and A is called the proposition and B is called the evidence. See here, P A and P B both are the prior probability. Yeah, because they are independently, we can calculate it, right? So, but the P A is called prior probability, but it is the probability of proposition, and PB is the probability of evidence. So P A by B is the posterior probability, and B by A is the likelihood. So the Bayes theorem is like that: that prosperity equal to likelihood into proposition prior probability by evidence prior probability. So thank you.
Hello everyone, I am Konak Sunal. I am going to define about the Bayes theorem. Bayes theorem is the probability theorem which shows the relation between the conditional probability and its reverse form. For example, probability of a hypothesis which given some observation pieces of evidence, and the probability of that evidence given to the hypothesis. And this theorem was named after that Thomas Bayes, and then after that it called the Bayes law or Bayes rules. Thank you.
Hello everyone, my name is Ripunja Bordule, and I am from Integrated MSCIT, and I am in 9th semester. So today I am giving about the topic of a brief description of naive-Bayes theorem. So what is naive-Bayes theorem? It is a classification technique based on Bayes theorem with an assumption of independence among predictors. In simple terms, a naive-Bayes classifier assumes that the presence of a particular feature in a class is unrelated to the presence of any other feature. For example, a device may be considered to be an umbrella if it is yellow, round, and its radius is 45 centimeter. Even if these features depend on each other or upon the existence of other feature, all of these properties independently contribute to the probability that this device is an umbrella, and that is why it is known as naive. So I'm explaining now the workflow of classification workflow. Whenever you perform classification, the first step is to understand the problem and identify potential features and label. Features are those characteristics or attributes which affect the results of the label. For example, in the case of a loan distribution, bank managers identify customers' occupation, income, age, location, previous loan history, transaction history, and credit score. These characteristics are known as features which help the model classify customers. The classification has two phases, a learning phase and the evaluation phase. In the learning phase, classifier trains its model on a given dataset, and in the evaluation phase, it tests the classifier performance. Performance is evaluated on the basis of various parameters such as accuracy, error, precision, and recall. Thank you.
Good afternoon, everyone. Myself, Meghna Bane from MCA. Today, I will discuss about naive-Bayes classification algorithm. Naive-Bayes classifiers are a collection of classification algorithms based on Bayes theorem. It's not a single algorithm, but a family of algorithms sharing a common principle, that is, every pair of feature being classified is independent of each other. Considering an example weather condition for a particular day, where the temperature has nothing to do with the humidity or the possibility of the day being rainy. Also, knowing only the temperature or humidity alone cannot predict the outcome accurately. They are independent of each other and contribute equally to the outcome. Thank you.
Hello
Good afternoon,
everyone.
everyone.
Okay.
Good afternoon, everyone. Myself, Nilav, and the knife-based algorithm is a probabilistic machine learning algorithm that can be used to classify the classify the wide variety of classification ducts. It is used to basically filtering some data, filtering spams, and classifying documents, sentiment prediction, etc. It is called naive because it doesn't know the value of the other features. It assumes it only knows its own value and it doesn't know the features of the independence to each other. Uh, and the changing of one feature does not directly affect the other features. And the Bayes theorem is posterior probability is equal to likelihood into prior probability divided by the evidence. Thank you.
Hello everyone. Myself Dibya. I am from MSIT third semester. Today our discussion topic is knife-based classification algorithm of a third recognition. Knife-based theorem is a classification technique based on Bayes theorem with an assumption of independence among predictors. This theorem introduced by Thomas Bayes. A knife-based classifier assumption that presence of a particular features in a class is unrelated to the presence of any other features. Mainly, knife-based model is easy to build and particularly used for very large data set. And the Bayes theorem mainly calculating the posterior probability with the help of likelihood, classifier probability, and predictor probability. With the help of naive Bayes algorithm, we can analyze the real-time prediction, multi-class prediction, text classification, spam filtering, sentiment analysis. Thank you.
Good afternoon,
Someone
everyone.
please speak. Okay. Okay, Vandan, you can speak.
Good afternoon, everyone. My name is Bandan. I'm So today's topic is named by the the collection of classification algorithm based on Bayes theorem. It is with Bayes theorem where all of them share a common principle, that is every pair of features being classified is independent of each other. Consider consideration that is for length of given the condition its classification as fit or unfit for playing for prediction. So thank you.
Someone please speak because I'm noting down the names. So if you'll not be speaking, you'll not be getting the attendance, and the time is also limited. So out of 19, only 9 have spoken. Other 10, please speak at least one line.
Hello, welcome to everyone. So today I will speak. This is a process of classification that is based on the fact that the presence of other features of a class are independent of different features. So we use this naive-Bayes theorem to predict the posterior probability of a class, that is given by the formula like probability of class divided by that attribute is equal to the likelihood that is given by probability of the attribute divided by the class multiplied by probability of the class and the whole divided by predictor prior probability. So I'm not just having the slide, so I'm not able to show the formula. So as it is already someone shared above, that is the way to calculate the posterior probability. So this is the knife based classification, and we can sort out many, like most of the complex classification tasks by using this knife based model. So thank you.
Uh, Hello everyone, my name is Jaish and I'm going to talk about the knife base. Knife base is a simple technique for constructing classifiers models that design classes labels to problem instances represented as vectors of feature values, where the class labels are drawn from the finite set. There is not a single algorithm for training such classifiers, but a family of algorithms based on a common principle. All knife-based classifiers assume that the value of a particular feature is independent of a value of any other feature. Thank you.
Hello, my name is Fayaz Pochar, and today I'm going to say something about net-based algorithm. It is a classification technique based on Bayes' theorem with an assumption of independence among predictors. In simple terms, we can consider as a Bayes classifier assumes that the presence of a particular feature in a class is unrelated to the presence of any other feature. If we take an example, let us take an example. A fruit may be considered to be an apple if it is red, round, and around 3 inches in diameter. Even if these features depend on each other or upon the existence of the other features, all of these properties independently contribute to the probability that this fruit is an apple. And that is why it is known as naive. Naive-based model is easy to build and particularly useful for very large data sets. Along with simplicity, naive-based is known to outperform even highly sophisticated classification methods. As you can see the Bayes theorem equation in the slide. Um, thank you.
Good morning, good afternoon. Am I audible? Hello,
Yes, yes, you're audible.
myself Vishwajit Gogoi. I am going to tell about naive-Bayes algorithm. What is naive-Bayes algorithm? It is a collection technique based on with an assumption of independence among predictors. In simple terms, a naive-Bayes classifier assumes that the presence of particular feature in a class is unrelated to the presence of any other feature. Naive-Bayes model is easy to build and particularly useful for very large datasets. Along with simplicity, naive-Bayes is known to out- outperform even highly sophisticated classification methods. Thank you.
Good afternoon. My name is Rutipan Bora. Today I'm naive-based classification algorithm. As the name suggests, naive, naive that it has a little experience, not to a great extent. The naive-based algorithm is based on the Thomas-based algorithm, where the naive-based algorithm is not only a simple algorithm; it's a collection of base. In Bayes theorem, there is an assumption that every features of a particular object is is independent of each other, and it holds exact value to the outcome of the operation. The naive-Bayes algorithm is generally used to classify the testing data into different classes. It is easy to it is useful to classify that data even it has multiple classes. Uh, as we said that the naive-based classification algorithm holds all the features as equal. Let's consider as an example. Example that today is going to be rain. It is going to be rain. The factor humidity and the temperature, it all holds the same values. The naive-based algorithm is a the naive-Bayes algorithm formula that probabilities of something happening, that target is given the predictor x is equal to probability x over c, and the probabilities of c divided by probability x. The posterior probability generally we calculate using using the prior probability, which is the likelihood, with the addition of the likelihood. Thank you.
Four attendees are still left who have not spoken till yet. So please speak something at least.
Good afternoon, everyone. Am I audible?
Yes, you are audible.
Thank you. This is Nibir Goswami of MCA 5th semester, and today I'm going to discuss about the topic net-based algorithm. So it is a classification technique based on Bayes theorem. It assumes that the presence of a particular feature in a class is unrelated to the presence of any other feature, with an assumption of independence among predictors. Naive-Bayes model is easy to build and particularly useful for very large datasets. Along with simplicity, it is known to outperform every highly sophisticated classification methods. For example, an object may be considered to be a cricket ball if the color is red and the shape is round and the size is about 3 inches in diameter. If these features depend on each other or upon the existence of other features, all these properties independently contribute to the
Hello, Nibir. You are not audible. Hello. So now only two attendees are left, Fardin and Jyoti. So I request you to please speak at least one line because the time is limited. We'll be finishing this in 1:20. So please speak at least one line.
Good afternoon, everyone. Am I audible?
Yeah, you're audible.
Yeah, my name is Fardin Ahmed. Today I'm going to say about naive-Bayes algorithm. What is naive-Bayes algorithm? It is a classification technique based on Bayes theorem with an assumption of independence among predictors. In simple terms, a naive-Bayes classifier assumes that the presence of a particular feature in a class is unrelated to the presence of any other feature. For example, a fruit may be considered to be an apple if it is red, round, and about 3 inches in diameter. Even if these features depend on each other or upon the existence of the other features, all of these properties independently contribute to the probability that this fruit is an apple, and that is why it is known as naive. Thank you.
Hello, I'm Jyoti. I'm going to discuss about naive-Bayes algorithm. It is a classification technology based on Bayes theorem with an assumption of independence among predictor. In simple terms, a naive-Bayes classifier assumes that the presence of particular features in a class is unrelated to the presence of any other features. Thank you.
Okay, so thank you. Actually, here everyone have attended the discussion. So Joyda, Kashyavik, Konok, Ripunjoy, Meghna, Nilop, Dibyajyoti Sharma, Bandhan, Dhitiman, Rahish, Fayaz, Biswajit, Ritupon, Nibir, Fardin, and Ripjyoti and me. Okay, that is a good thing. Okay, so thank you for this discussion.
Thank you.
Am I audible?
Yes, sir. Yes, sir, you're audible.
Yes, sir.
Yes. So, what you have found means whether this discussion was interactive or not.
Yes, sir. Everyone have participated. Total 18 students are there, so total 18 students have participated.
Okay, very good. As this is the first session of this type, so I hope that in the next session, whenever I will means organize this, everyone will prepare it fully and keep at least 2 or 3 figures and 1 or 2 slides with respect to that discussion. Right? This will help you to present you about that topic in much better way. ठीक है, नेक्स्ट सेशन जब भी होगा आप लोग कोशिश कीजिएगा कि अपने पास 1-2 स्लाइड्स ऐसा रखो जिससे इसके बारे में आप अच्छे से बता पाओ और बाकी लोगों को भी ये समझ में आए, ठीक है। और बाकी ये सेशन बहुत अच्छा था एंड आई वुड लाइक टू थैंक यू अंकित, Joyita, Kaishavi for maintaining the flow and smoothly conducting the session. And thank you all of you who have participated in this discussion. And in every week, I will try to organize this type of sessions. Okay, I hope that will help you, isn't it? Will this help or not? I
Yes,
want
sir.
to know.
Yes, sir.
Yes,
Yes,
sir.
sir. Sir,
Yes,
the
sir.
PPT. How can we share the PPT? Actually, I'm trying to share, but I'm not able to share the PPT.
Is you will see an sharing option there. Okay, you just need to
Yes, sir.
click that, and in front of you there will be several options like you need to share the desktop, or you need to share the you want to share the presentation slides only. Okay, a lot of option will be in front of you when you click that option. Okay, that will be like rectangular type of box. Okay.
Okay. Okay, sir.
So I hope we can terminate this session now. We'll
Yes,
meet in
sir.
the next lecture with this topic to be continued with one more practical. And I'd like to thank you again, all of you. Have a nice day. Bye bye.
Thank you, sir.
Thank you, sir. Thank you, sir.
Thank you, sir. Thank you, sir.